In this video, we'll be seeing how to calculate the area enclosed between two curves. The first one being y is equal to x squared plus x minus 2, and the second one being y is equal to x minus 1. It's often a good idea, when doing this, to start by making a quick sketch of the situation. If I make a quick x and y grid here, x and y, and if I plot the two curves, typically you could be doing this with your graphical calculator, you should see that we have something looking like this. The first curve looks something like this. That's y is equal to x squared plus x minus 2. And the second curve, which in this case is just a line, looks something like this. Now, in video 1, we saw that to calculate the area enclosed between the two curves, which is this area I'm currently hatching now, the first thing we have to do is to find the values of x at which the two curves intersect. Those are the 2 points I'm highlighting in blue here. In other words, we need to find this value of x, which we'll call a, and the second value of x, which we'll call b. To do this, we have to focus on the two right-hand sides of the curve's equations. What I mean by that is, I'm going to focus for a second on x squared plus x minus 2 and x minus 1. And our step 1 is going to be to solve x squared plus x minus 2 equals to x minus 1. Solving this equation will lead us to the two x values at which the two curves intersect. So let's get started. Gathering all the terms on the left-hand side leads us to x squared plus x minus 2 minus x plus 1 equals to 0. And we can see right away that the two x terms cancel out, and negative 2 plus 1 is equal to negative 1. That leads us to x squared minus 1 equals to 0. Carrying on, we obtain x squared equals to 1, which remember has two solutions, x equals to negative 1 and x equals to 1. We now have the two values which I called a and b in the diagram above. If I scroll back up quickly here, we have a is equal to negative 1 and b is equal to 1. Now, the second thing we have to do, step 2, is to use the formula for the area between two curves. Remembering what we saw from video 1, the formula for the area between two curves was area is equal to the absolute value of the definite integral from a to b of the first curve's equation, which in this case was x squared plus x minus 2, minus the second curve's equation, so minus x minus 1. Do remember to write these in parentheses, in particular the second one, in order to avoid sign errors. Now, we know that the values of a and b are a is equal to negative 1 and b is equal to 1. We found those two values in step 1. So we can go further now and say that the area is equal to the absolute value of the definite integral from negative 1 to 1 of x squared plus x minus 2 minus x minus 1. We now have everything we need. So let's start working through this. This leads us to the absolute value of the definite integral from negative 1 to 1 of x squared plus x minus 2 minus x plus 1 dx. In turn, this will lead us to the absolute value of the integral from negative 1 to 1 of x squared minus 1 dx. This leads us to the absolute value of x cubed over 3 minus x from negative 1 to 1. Finally, or nearly finally, this will lead us to 1 cubed minus 1 minus negative 1 cubed over 3 minus negative 1. This now leads us to the absolute value of this first bracket here. Leads us to 1/3 minus 1 is negative 2/3 minus negative 1/3 in parentheses plus 1. This leads us to the absolute value of negative 2/3 minus 2/3. This leads us to the absolute value of negative 2/3 minus 2/3, which leads us to the absolute value of negative 4/3. And of course, the absolute value of negative 4/3 is 4/3. So the area enclosed between our two curves is area is equal to 4/3, or if you wish, that's roughly equal to 1.33 units of area. And there we go.